The following teacher development program is brought to you by the MultiChoice Africa Foundation.
Just 3 kilos to go. Oh! Damn it. Hi, Peter, it's me. Look, man, I was running up Melville Koppies and I twisted my ankle. Can you help me? What? Okay, I'm just gonna have to make another plan then. Yeah. Damn it.
Yes, hello?
Lebogang,
Yes, Thandi. What's wrong?
I was running up Melville Koppies and I twisted my ankle. Please come and fetch me.
Of course. But where exactly do I go?
I'm not sure, but if you have a compass, we can work it out.
A compass?
Yeah, like for measuring directions, right angles. You did geometry, didn't you?
Wait a minute. Thandi, is this a joke or what?
It's not a joke. Lebogang, please just come and fetch me.
Okay, I'll get one from the geography teacher. But where do I go?
Look, I started at the 4th Street gate. Maybe that would be a good place to start.
Okay, cool. I'll get everything, and then I'll call you from the gate.
Okay, thanks, man. I'll owe you one.
Okay, fine. Bye. Hey, Thandi, I'm here.
Have you got your compass?
Yes?
Okay, go up the hill 10 degrees east of north.
Wait. You're getting too complicated already.
Now just look at the needle pointing north, okay?
Yeah, but how do I do that?
Well, turn your body till the needle is in line with the north on the compass.
Yes?
Now find east, it should be clockwise from north. Then look at the scale between north and east. You'll see some numbers. It goes from 0 degrees, which is north, to 90 degrees, which is east.
Okay, it's in line with that 3. Okay. I'm turning 10 degrees northeast.
Not northeast, it's east of north.
Thandi, what's the difference? Northeast, east of north?
Northeast means exactly between north and east. It's better to describe directions in degrees. It's more precise.
I can't believe you're getting all particular about maths terminology while you were stranded.
It's important. Instead of talking about northeast or northeast, use degrees. Northeast, being exactly between north and east, is 45 degrees east of north. Hello?
Yeah. I think I'm getting your directions. So now I'm starting to walk. Thandi, how long do I continue to walk this direction?
Well, till you get to a huge bunch of rocks.
Thandi, I found them.
Okay, now move towards southwest.
Don't you mean such and such degrees? Southwest, Miss Precision.
Well, I just thought before I give you directions and degrees, I would give you a sense of more or less where you should look.
Okay. I'll start with the north on the campus. Southwest will be on the anti-clockwise direction between west and south.
Yeah, that's a general direction, but to be mathematically precise, head 120 degrees west of north.
Okay. How do I measure these degrees? From the west?
Listen, 120 degrees west of north.
Oh, 120 degrees west of north. So I should start from the north.
Well, yeah, north is your baseline, your 0 degrees.
And because it's west of north, then I have to turn west or anti-clockwise if I want to measure degrees.
Yeah, and please hurry up.
Ah, man, Thandi, man. It's not working, man. I'm getting confused, man.
Okay, try this. Look, you've got north. West is 90 degrees west of north.
I've got 90 degrees spot on. Right angle. So I guess I have to add that with 30 degrees. That is 90 plus 30. That's 120 degrees. 20 degrees. Okay, I'm starting to walk now.
Okay, I'm just over the hill. Come get me, Lebogang, please. Damn it, it's gone dead.
She's scared. And she's alone. Pretend you're a clever kid in a math literacy class. Get it right, boy.
Mike Maynard from Germiston High School is teaching a lesson in mathematical literacy on angles and bearing. He starts off by introducing the concepts.
With directions, it becomes very, very important. We need a couple of basic principles, all right? We've got the atlas I've got over here. This deals with a nice flat projection. What they've done is they've taken this globe and they've taken it and they've flattened it. With direction, there's something else that becomes very, very important, and that is
position.
To indicate bearing, you need two things, the direction as well as how far you should travel. In this exercise, the learners will make a spinner to indicate in which direction they should travel, and then throw the dice to see how far they should travel. They make a spinner out of basic materials.
What the spinner consists of is the two papers with the directions. We've got a washer on the top. We have a drawing pin underneath, and we have a straw with a society stick stuck through it.
Now the learners have to see where they are going on their holiday around the world. Once the Dyson spinner shows them where they're going, the learners use a world map to look at the country or town.
Our group went to the Eastern Islands in the Pacific Ocean, and I almost vomited right on the way in the sea. And Someone else went to Brazil just only to see Ronaldo, and someone else went to Australia just for the hell of it. Other one went to Italy just for the Italian shoes.
Mike explains how direction is indicated on a compass.
The compass that I've got in front of me here, this is a hiker's compass. This one will show me all the particular directions I require. Not so. And if you look at this, you'll see that we've got our north, south, east, and our west. We've got the big points in between. And what I've done is I've shown you that there are actually points in between those.
Mike explains that angles are measured in different ways for mathematics and for geography.
In geography, where is the north? The top. We say that is 0 degrees. All right? Where is east? This side. We say that is 90 degrees. Obviously, I'm going to have 180 and then 270 degrees. In mathematics, it's different. Look at your protractor again. Where is the 0? Where is the 90? Where's the 180? 0 is on the side. It's on the side. Where's the 90? At the top. Here's 180. There is 270. And back to the beginning for 360. So you, when you work with mathematics, must remember this one.
In the next exercise, learners draw and measure different angles. Some learners are adventurous and venture beyond a simple acute angle.
Sir, how do you measure this angle?
This large angle, let's extend one of these lines, either this line or that line. Draw an extension. Now you know that this is 180 degrees. Okay. So you measure this piece in between. Then you add that to the 180 and you'll be able to measure angle.
64, 74.
74 degrees, right? So write in your 74 there. And now you add it to 180 degrees. So we get an angle of 254 degrees, which means it's larger than 180, but smaller than 270. What do you call that size angle?
Reflex angle.
Excellent.
Mike explains that there are different ways to measure direction, depending on the baseline you are measuring from and which way round you are measuring.
If we're going to move to the right-hand side, we could actually say that we are east of north. So we're going to be east of north. We could also say we could be south of west. There's the south, there's west, there's west. So we're going to be south of west, so we're going to be in this direction. If we look at, say, 10 degrees, 10 degrees is going to be in this direction, according to the compass. But we could also say that we are 10 degrees east of north in that particular direction.
In the next exercise, the learners have to plot a flight course for an aeroplane. They have to say what direction different towns are from Bloemfontein. What transpires is that we can measure the same direction in different ways.
Do we have to start clockwise, going like this, adding 180 degrees, and then go like that? Or should you just take 180 degrees and take it from there?
I think first you do this, right? And then you make it like this. It's just going to be 180 degrees. Yeah.
What you can do is to put it like this. All right? And on that line now, I'm measuring, which scale do I use? Inside or outside?
Outside.
Inside. So I'm going 10, 20, 30, about, what's that? 38 degrees. Now we've measured 38 degrees. We're moving downwards of?
West.
There you go. So it's 38 degrees south of west. There you have it.
In the final exercise, the learners have to plot a course for a ship to sail from Cape Town to Bombay. They're not allowed to cross any land masses.
Navigation course from Cape Town to Bombay. It can't be a straight line by boat, not so. Because then we'll be going over the continent and we might even crash into Madagascar. When you plot this course, you will have to plot it in short little sections, depending on how you're going to go. And what you're going to be working with now is bearings. So what you need to do is have a starting point, and you need to have an end point. And then obviously you're going to draw the line from start to end. What you need to do is you need to be able to measure with your protractor. Which compass do we use? The mathematical compass or the geography compass? Geography compass. So you start here and you measure there. So this is the angle that becomes important. Then when you get to this portion and you stop, you then draw another cross and then you decide you're going that way. And then you measure again from there to there, and that will then be your angle. If you look at these two solutions that these two navigators have come up with, you'll see this one on this side is nice and stepped, and this one on this side is relatively straightforward. But my question to you is, what would be the advantage of this one?
Okay, it will be easier to steer because it's like 90 degrees.
What would a disadvantage be of this route?
The disadvantage of that route is because you have to go a long way before you start turning, because you'll be taking a lot of fuel to turn, so it's better just to cut through the space. The disadvantage is fuel.
There are many ways to teach angles and bearing. By making the lesson fun and relating it to real life, Mike has made a lasting impression on the learners.
I was getting out of my head. Okay, let's see. Where's the problem? Okay, yeah. See?
Ouch.
Okay. Before we go down, I think we're gonna have to put this on for a while.
Peter would have never thought of that. It's a good thing you found me before these got defrosted.
Yeah, hold on to this. I brought you this. I thought you needed some sugar.
I'd be a stranded traveler with you any day.
But you're lucky this is Melville Coffees. Imagine if you're on a flight that goes down in the middle of nowhere. I bet your compass reading 101 is the first class the pilots take.
As a little boy, I wanted to become a pilot, and I was told that I had to have maths. While I was at school doing mathematics, I did not see the reasoning of trigonometry and some of the mathematics that we were learning. However, when I became a pilot later on in life, suddenly everything, it was like a bright light that got turned on in my head. And all the formulas of cosine, cos, and tan, and the cosine rule, and all of that suddenly became apparent because you use it all the time in navigation. In navigation, when you are traveling from one point to another point, you have things that affect the aircraft like wind drift, or there's a mountain in the way that you've got to go around it and then you've got to come back onto track. By virtue of the fact that you know that you've traveled that distance, you've still got that distance to go, and you're at right angles and you search that distance off track, you can work out the angle here that you were off track, and then by applying it to the calculation, you can then rework your angle that you have to steer to get back right onto your track. In the cockpit, there's maths being used all the time to work out things. With the advent of the GPS, it's one of the most accurate forms of navigation nowadays, to up to within 50 centimeters of where you have to go to. We're actually at south 25, 56 minutes, 0 seconds, and east 27, 55 and 20 seconds. Now that is about 100 meters from the actual point on the Earth from where we are.
I think I can walk now.
No, not so fast, not fast. Listen, I'll walk you down slowly and very carefully. Come. No.
My, you are the hero today.